We see it on TV all the time, but now today we go to the research lab. We're talking DNA forensic science next on the show. Welcome to Mendelspod, everyone. I'm Theral Timpson. Today's episode is brought to you by Twist Bioscience, enabling customers to succeed through its high-quality synthetic DNA offerings using a silicon platform. This week, as we celebrate International Women's Day, we're spotlighting the groundbreaking contributions of women in science, and our guest today is Dr. Mirna Ghemrawi. She is at the forefront of forensic genetics, applying next-gen sequencing and AI to solve critical new questions in this field. Originally from Lebanon, Dr. Ghemrawi serves as an associate director at the Center for Forensic Science Research and Education, focusing on forensic biology, genetics, and epigenetics. Dr. Ghemrawi, welcome to the show.
Thank you. Thank you so much for having me.
Forensic science sits at that fascinating intersection of biology, chemistry, but also justice. And your work has had a real world impact in many ways that we see, as I said, in crime dramas or read in the news. So let's start with your journey. Can you share some highlights of your path into the front lines of forensic science?
Yeah, of course, it would be my pleasure talking to you today. And the journey to forensics was a bit interesting, I would say. I started actually in the medical field. So I did my undergrad back home in Lebanon in medical lab sciences. I always knew that I have passion to forensics. I wasn't sure how can I follow that dream as there wasn't that many opportunities back home to really go into the forensics field. But I knew I need the fundamentals anyways. So being in any science related field will help me towards the biggest dream. And then I was fortunate enough to get a full scholarship to come to the United States on a Fulbright scholarship, and I got to do my master's in forensics. When I did my 2 years in forensics, particularly forensic biology, I was like, I want to learn more. I feel like my curiosity was not yet fulfilled. I really wanted to have more hands-on experience, more research experience. So I decided to pursue my PhD. So I went down to Miami, did my PhD in biochemistry as a degree, but all of my research was related to forensic genetics. And then got the offer to join the CFSRE, or the Center for Forensic Science Research and Education, as the associate director, as you said, in forensic biology. And then since then, I've been mentoring students, doing research, teaching, doing some outreach to the community, and I really love it.
Okay, so just to be clear now, there are people who work with specific cases, right, to identify. You're more on the research side. So what are some of the hot topics on that research side that's changing forensic science?
Yeah, so now, like if you see the news, a lot of topics are talking, or a lot of news is talking about forensic genetic genealogy, which is trying to find, an individual through family trees on like open databases. And also you have another topic that's also like a bit of a hot topic, also known as TPPR, or DNA transfer, persistence, prevalence, and recovery, like how the DNA is there. It's not, now the methods are so sensitive that we can get a DNA profile out of like a very minute amount of sample. The question comes, okay, how did it come? Was it direct transfer or indirect transfer? And so on and so forth. And that's where the challenge now is, I would say, in the court system, when the prosecutor or the defense would start that type of argument as how the DNA arrived, or also known as activity level type of reporting.
Okay, interesting. Yeah, so some investigator may find DNA evidence, and when we watch the movies, we think that's it. But now new questions could be pushed by the defense or the opposite team, could be the prosecutor, questioning how the DNA got there.
Yep.
Are there how are we able to do that better? How's it gotten more sensitive?
So the method of actually getting the DNA profile became more sensitive. That, as I mentioned, like from very minute amount of DNA, you can get a partial or a full profile. It's just like how the technology has been enhanced over years and years and years of research and scientists thinking of quicker ways, better ways to actually get your DNA profile. But that added that other layer of, okay, again, how the DNA has been transferred or how is it persistent or prevalent or recovered from an evidence.
Okay, so we can do sequencing on much smaller sample sizes. Um, and so what became comes the big challenge in finding where it came from?
The challenge would be there are a lot of awesome researchers. I don't necessarily do research in TPPR. There are
Uh-huh.
out there a
Oh,
lot
okay.
of
Hmm.
awesome researchers who are really working on different Bayesian network models and different ways to really scientifically talk about the transfer of DNA as an example. So it's just a matter, I think, of time and doing more research and educating the community as to what it entails to talk about that specific activity level propositions.
Okay, so you start talking about Bayesian analytics. It seems like every show we do now is talking about the use of AI in biology. Um, what kind of technology, what new technologies are impacting your work?
So definitely I am pro emerging technology. So now we say sequencing, and if someone is in probably the clinical or medical field, they're saying, oh, sequencing is not anymore like really emerging. We're using it, in clinical cases. But in forensics, it tends to be a bit slower in adopting emerging technology. So we still
Okay.
consider it as like emerging sequencing based type of DNA testing. So that's where my focus is really is not only the genetics element of forensics, which is used for human identification, but also other types of markers in our DNA, particularly what we know as DNA methylation or epigenetics, that will provide you with additional type of information that the genetics element of our DNA would not be able to tell us.
Okay, and let's dive into that a little deeper. I know you're working on a project with Twist Bioscience where you're looking at genomic and epigenetic markers. Can you tell us about that? What's your goal there? What you're doing?
Yeah, so this it started with just a crazy idea when I first read a paper that again it was for oncology and clinical use about a chemistry that allows you to look at both the genetics and epigenetic markers at the same time. And again, the application was purely non-forensic related. I read that paper; it was published in Nature, and I was like, that would be very interesting if we can exploit it for forensic purposes. I knew that I wouldn't be able to just do whole genome, which what they did in that paper, because forensically because of the amount of DNA and for privacy concerns, we really cannot do like whole genome. It's not a common practice, I would say. So I knew that I need to couple it with a different chemistry, and that is known as hybridization capture. And that's where I talked to Twist and Biomodal, these two companies, to just explore how can we leverage both chemistries together and be able to apply it for forensic cases. So the idea was not only that we can get human identification out of that technology, but also can we identify the fluid through the epigenetic markers, as well as other phenotypic features like age prediction. And if we add more like SNPs and other things, we would be able to get more information from the same sample at the same time in the same sequencing run, which to the best of my knowledge, I don't think it has been done yet in forensics, combining again these two chemistries together and trying to answer forensically relevant questions. So it's still in its infancy, I would say, but the proof of concept study that we did was really promising. I've published, or not really, I'm working on the publication, but I've shared some of the findings in some conferences, and I've got really awesome feedback from the scientific community, from the forensic genetics community, saying that they've been waiting for something like that because it was that missing piece of the puzzle. Is a way to do both of them at the same time.
Okay, so let's say this works out. And it sounds promising, as you say. What kind of questions might that help with?
That's an excellent question. While again, I do have to put a disclaimer that we still need a lot of, to do more optimization and to really look into the sensitivity and the specificity of it. But at least I can talk from that proof of concept study that we did. So if we take a scenario where, for example, we have a mixture of a sexual assault, and we have a mixture of, let's say, semen and vaginal fluid.
Mm.
If you do like the conventional testing, you're going to see a mixture of DNA. You can apply, probabilistic genotyping to try to deconvolute the mixture, which is again the common practice right now. If this method becomes validated and be used in cases, and would be able, let's say, to use it for the same scenario, we would be able to identify the fluids. So say we can say that this is a combination of vaginal and semen sample. So that's one.
Mm-hmm.
Two, if we can find SNP markers around methylation markers that are fluid specific, it might be easier to deconvolute the mixtures. So you can say that this semen, it has been, let's say you have two males in this scenario. So semen, blood, and vaginal, make it more complex, right? So you have these three individuals, but who contributed the semen versus who contributed the blood becomes a hard question to answer with the current technology. So the hope in this technology is that can we help easing up a bit that deconvolution and fluid contribution to a particular individual. That's one application.
That's one thing, tracking down the source again. Yeah.
Exactly. The other application is, let's say, in cases where you don't find a hit in the CODIS database. If the individual is not in the database, it becomes cold case. Can you predict the age of the individual or other phenotypic features like eye, hair, and skin color, or other features that would help in doing more like search
and doing a hunt? Yeah. That you could predict what the person looked like.
Exactly, what they look like, what the estimated age, and then if you're doing genealogy like you're now doing in some cases, adding this tool to it becomes really powerful because it will help narrow down that family tree that the genealogists build when they do their FGG or FIG cases.
Oh, fascinating. Fascinating. Yeah. So I'm guessing that the forensic science is slower than clinical because there's just so much at stake here. And so they have to be very, very, very conservative. We hear these stories of someone going to prison for life or whatever, and it turned out the DNA evidence was wrong.
Yeah, so you're right. So there are many stakeholders that are different from the clinical, right? You have the criminal justice system where you have to have a method that the community, approves. It's been peer reviewed, it's been accepted, validated, tested. You need to educate scientists on how to use the technology. Sequencing, again, it's not something that they do on a daily basis. So you need to educate them about what sequencing means, how you can analyze the data. Then there might be a question about privacy and ethics. Are you getting more information than what you need from that evidence, let's say? So getting that all sorted out, and so it become admissible in the court takes a long time.
Is forensic science as exciting as you dreamed it would be when you were young?
It's definitely exciting. I still love it. I love anything related to science, really. And forensics aspect of it adds this like glitter aspect, like more satisfaction for me. I'm still exposed to the clinical. I still am interested in reading literature related to, things related to disease and other things like that. But the forensics aspect of it and the hope that we can help the community and supporting or developing newer methods that in hope it will solve more cases has always been a dream of mine, and I'm hoping that I can even slight contribution to the community is really rewarding for me.
For sure. Yeah. So I guess that's the big dream, the big goal, the big vision is to be able to solve more cases. Talk to us about how you see the field evolving. Of course, there's this new project you're working on, which sounds very promising. Just if that, you know. But how do you see the field changing? Do you think it's early days for forensic science, or we figured most things out?
We've figured a lot of things out, but I think there are still a lot of other things that we need to figure out. So I feel like maybe we're in somewhere in the middle, maybe. I feel like given that the technology is improving day after day, new instruments and new chemistries and new technologies are on the horizon. You can see it clearly in again in the clinical field. I feel like we can do much more than what we currently do. Obviously, we have our own type of challenges when it comes to forensics, let alone all of the logistics and bureaucratic and like the law aspect of it. We're talking also about the type of evidence we receive. Like in a clinical setting, you don't have issues in receiving the quantity of your DNA, right? And in forensics, it becomes challenging because oftentimes it's a mixture, it's degraded, it's been exposed to the environment. You're working with very minute amount. Labs tend to be more conservative on how much of the DNA they want to use because they want to keep an aliquot out there just in case the case is reopened and they
Comes
want to
back.
reinvestigate again. So these types of challenges, we have to consider them when we apply any newer technology and test these the sensitivity and specificity again and accuracy and precision of these newer technologies because we do want to be more conservative. We want to make sure that the rate of error rates or false positives are minimal or non-existent if possible. And yeah, so I think if back to your question, long story short, is that we're in the middle. If we can accept the adoption of new technology and we are willing to invest in our scientists and teach them what the new technologies mean, how can we exploit them, how we can develop methods, how can we use them for forensic cases, and then convincing also the funding agencies to trust scientists that they're capable of developing newer methods, to give them that space to really explore new ways to solve cases is where we need to be heading.
The funding issue is on everyone's mind today. Yeah, that's big for all of science. Well, thank you for talking to us about this for International Women's Day. It's really been interesting. I haven't talked forensic science for a long time. As we go, any advice you'd give to other women going in this field or anyone going into this, young people going into this field?
Yeah, I love this question, and I think I I think the advice number one I would say is that the only way you know that you cannot do something is by trying, and you should start. You just start somewhere. Again, as I mentioned, I didn't start in the forensic field. I started clinical because that's what I had an opportunity to study. I loved it, by the way. I just knew that I want to pivot eventually to forensics. I was not afraid to ask questions. And I think this is a big thing too. When a student is intimidated, because I teach now and I try to, and I mentor students, I always emphasize the importance of being comfortable in asking questions, no matter what type of question they're asking, whether they think it's a minimal, like I should know the answer type of question, or it's really a big, crazy question that it might be not too logical. I might be judged if I ask a question. I feel like we need to break that, myth or whatever our fear of asking questions and connecting with people. Like I would always encourage my students to be on like professional platforms like LinkedIn, for example, and try to connect with professionals in the field. And they can start with a small group of their professors, their classmates, and from there they can be bigger and bigger, and then they can basically hopefully find a newer employer or the new employer in these type of platforms. And we can only do so is by seeing some examples. I hope I can be a good example for the newer generation, whether women or any other, gender. Really, it's about it might be a bit more challenging for women, maybe, and depending on what region and from this world are coming from, and the different types of, pressure they might be going through culturally and, whatnot. It's never going to be easy, but you can do it if you really put your mindset that I am capable of doing so and I want to work on myself. Like the scholarship, all of the scholarships that I got and the fellowships that I got, I knew that this is what I hope I can get. I worked on it as early as I knew that I want that. For example, scholarship, but ultimately I'm a strong believer that whatever happens for the best, for a good reason. Like God always has the best plans for us, but I have to do my best. I cannot sit lazy at home and say, oh, whatever happens, gonna happen. I have to work for it, and just be out there and be okay in being a bit uncomfortable. If you don't know everybody around you, it's okay. It's going to be rewarding eventually.
Dr. Mirna Ghemrawi, forensic scientist at the Center for Forensic Science Research and Education. Thanks so much.